right, we're going to go ahead and kick things off. So now for our next speaker, my friend first and coworker second, Jonathan McDonnell, hailing from Kinsale Insurance here in Richmond, Virginia. He's got about 2 years of software development under his belt, and in that time, he's become one of the best young developers that I've worked with today. Today, he'll be presenting on audio processing in the browser using Essentia.js. Without any further ado, take it away, Jonathan.
Thank you, everybody. Thank you.
When you're ready.
I always wanted to play piano in a bar. So yeah, thank you, Evan Scott, for that wonderful introduction. My name is Jonathan McDonnell, and like you said, I am based right here in beautiful old Richmond, and I'm so excited to share with you what I consider an intersection between two of my great passions. First, software development, of course, though that came a little later in life for me. My second, and what I would consider my original passion, is music theory, music composition. I've been playing piano for as long as I can remember. Started out playing some, public domain ragtimes. Thank you, Scott Joplin. Now I play some more jazz. Had a brief stint playing trombone, if I have any low brass people in the audience. Played in middle school, high school, college, at the University of Florida. Go Gators, I suppose. And so that's why, so undoubtedly music has been a huge part of my life, which is why I was so excited to play around with the topic of today's conversation, which is Essentia.js. That would help if that went to the right screen. 1 second, folks. All right. So Essentia.js. Before we talk about Essentia.js, though, we need to first discuss something else, Essentia. So Essentia is a C++ library. I know I'm at the JavaScript conference. Stay with me here. Essentia.js was developed by a university in Barcelona, Spain, the Universitat Pompeu Fabra, or just UPF. Within their Department of Engineering exists the Music Technology Group, which carries out research and development on topics such as computational musicology, which is a term I definitely knew before prepping for this. But part of their work was Essentia. And Essentia, like I said, is a C++ library with many different algorithms for processing music. Took about 10 years to develop, and for good reason. It's chock full of all sorts of different helpful algorithms. Essentia already sees professional application. A few examples that you might recognize right away. A company called Korg. They produce a lot of electronic instruments, recording equipment, guitar pedals. They have an iPhone application called Cortosia. Cortosia is a tuning app. In addition to tuning, it will use Essentia to try and evaluate the quality of the sound you're producing, which is huge for wind instruments. Another example is a company called Waves. They produce a lot of plugins for use in digital audio workstations like Ableton and FL Studio. All of these plugins help with mastering, mixing, post-production, and all use Essentia in some way. Another example, a game called Crypt of the Necro Dancer. You may have played this. It's really fun, really freaking hard. But if you're not aware, it's available on most all platforms. And the point of the game is it's a mashup of a rhythm game and a dungeon crawler. And basically, there's music playing in the background. Your actions have to happen on the beat, or you take damage, or you just straight up lose. They use Essentia for their what they call their beat tracking algorithm. So they will actually use Essentia to analyze the song to determine the tempo and the placement of the beat so that it can sync it up with what's happening on the screen. It also makes adding your own custom music very easy. You just upload your music and it can analyze it on the fly. So Essentia.js is undoubtedly, Essentia is undoubtedly very powerful. So what is Essentia.js? Essentia.js is a sort of wrapper library around Essentia to make it available to you on the web. The way this works, we need Essentia, the C++ library, to somehow be available to our JavaScript code. They use two different tools. First is mscripton to compile the library to WebAssembly. And then they use a tool called mbind to create a sort of binding layer to allow the JavaScript that you write to talk back and forth with that compiled WebAssembly. And Essentia.js is essentially this middle part right here. So we know Essentia.js is powerful. How do we start working with Essentia? Well, first, we need to bring it into our project. Nothing mind-boggling here to ways for you to do it. One way, it's delivered over a CDN. You can add the script elements into your HTML. You need to take in the JavaScript core library and then the WebAssembly backend. Or it's just available via npm and yarn, do a simple install or add, and it's in your project. Once we have Essentia in our project, we can create a new instance of it, passing in the module that we want to load, in this case, our WebAssembly backend. And then we can just start using it. In this simple example, I'm just logging the version and a list of algorithm names that are available from the C++ library. And we should expect an output that looks something like this. Essentia.js itself is very new and actually hasn't hit its version 1 yet. The Music Technology Group published their paper on Essentia.js in 2021. That's how new it is. But you see I'm actually logging a version 2. This is the version of the C++ library. And you'll see we also get a quite massive array that I've truncated for you of the names of all the algorithms available to you. I could honestly probably take up the full 30 minutes just listing all the algorithms and their use case and how to use them. But just a few examples. We have stuff for detecting the location of tempo changes or vibrato, or telling what key the song is in, or estimating where chords are and what chord is being played. All of these methods in Pascal case are from the C++ library. There are a few helper functions in the core JavaScript library, and you can spot them with the camel case at the bottom. They're usually just converting two different types. So now that we have Essentia.js in our project, first we need to get input to send to Essentia.js to do some fun stuff. So there's two main ways that we're going to cover. The first is the user uploads a file. There are honestly many ways to skin this cat. I'm just giving you a very simple example here of an input element of type file, so we can upload files. In my JavaScript, I'm pulling that element by its ID, adding an event listener to the change event that will fire whenever a file is uploaded. And then I'm just calling one of my functions, passing in the files array that is on my input element. And then I'm simply looping over those files, and I'm grabbing the byte array of that file by calling array buffer. Then we can use that byte array and pass it to our two algorithms to get some fun output. And here's just a very simple example of pretty much what I just showed you. I have my input element, uploaded my track, I'm logging out the array buffer. I can even inspect the memory with my dev tools. So the next way that we can read input, aside from uploading a file, is real time. As we saw earlier, I was playing my keyboard and got some output on my application. This way is a bit more complicated. Just to set the stage a little bit, we're assuming that I have some button that the user can press to start the recording, and I'm grabbing that button and listening for click events, and then I'm going to call my access user media function. So our first hurdle is gaining access to the user's audio stream, which is usually just going to be their microphone. The way we do that is by using this get user media method on the navigator object available in the browser. What this is going to do, you pass in an argument of an object with an audio and a video parameter. Set true if you want to request access to that stream, set false if you don't. We only care about the audio stream, so we're setting false for the video. For the user, they're going to, whenever this gets triggered, get a prompt that says, hey, this website is trying to access your microphone. Do you want to allow? Do you want to deny? That sort of thing. The thing about get user media, as a security precaution, it can only run in security context or in a secure context, which basically just means that your application has to be served over HTTPS, or else get user media will not be available, which is why we're doing a check for if it's supported at the top. And once the user gets the prompt, if they deny, we're going to actually enter into this catch block. We're going to say, hey, we couldn't access it. Here, I'm just throwing an error. But once we do get access, then we get the media stream from the microphone, and I'm passing that into my start audio processing function. So what does start audio processing look like? Well, like I said, it gets a little bit more complicated. We have to start talking about the browser's audio API and audio contexts and audio nodes. The best way that I can conceive of to introduce this topic is simply by example. So I'm actually going to go into my dev tools here. I'm going to clear all that, and I'm going to enlarge it. So before we do anything, we must create what's called an audio context. So the audio context is going to act as a sort of wrapper for all the really cool stuff we're about to do. The way we can do that, very simply, I'm going to create a context here and just call new audio context. And we're returned our audio context object that we just created. A few interesting things in here. We see that our audio context is now running, that we've created it. We also have this destination parameter in here that will be come in handy a little later. We also get the current time. The current time is the number of seconds since the since this session first started. So it's really helpful for syncing different things together. But the context itself is really just a wrapper, like I said. It doesn't do a ton on its own. To really get some fun things happening, we need to create what are called audio nodes. So I'm going to start creating a node here. We can take our context and we can call different create functions, and you'll see my autocomplete is showing me all the different types of nodes that we can create. I'm going to create, if you can't tell by my variable name, an oscillator node. We'll create that. We get the oscillator node back. You might be able to tell what this one's going to do just by the type sign, but the oscillator node is going to produce a sound at a certain frequency. You'll even see inside of here we have this frequency object with a value of 440. So it's going to produce a sound at a hertz of 440 hertz, or at a frequency of 440 hertz, which is the A just above middle C on my piano. But just like the context, the node just by itself doesn't do a lot. We need to connect it to something. The node, I want the output of this node to go to my speakers. And the way we connect nodes to things is we call, nothing mind-boggling here, we call connect on the audio node. But we need to pass in the thing that we want to connect to. Remember, our audio context actually has a default destination here that's actually pointing to my speakers. So we can take our context and pass in the destination from our context, or yeah, we can pass in the destination of our speakers. So now we have the oscillator connected. Now is for the fun part. If I call start on this oscillator node, woo,
it's always louder.
There you go. It's louder than you think it's going to be. But our oscillator node connected to our context is now creating that 440 hertz frequency. So I can now stop that node. So one node by itself is not very fun, I'll be honest with you. But you can actually chain nodes together and create really interesting chains that do a lot of things. The way this works is when you create your chain, we're going to do that with the connect function. We'll see that in a second. When you create your chain, the data is going to go from node to node. One node is going to either create data like our oscillator node, or take in data or modify data, and then pass its output onto the next node, and then to the next node, and then it'll end up at our destination, which is going to be our speakers. So I'm going to create another oscillator node. Funny quirk about the oscillator node is you can't call start twice on it. So restarting the oscillator node means creating a new oscillator node. So I'm going to create that oscillator node again, and I'm going to create another node, and I'm going to call this gain because it's a gain node. Wow. And we see we get our gain node back. What this is going to do is it's going to modify the volume of whatever is passed into it. So we can see here I have this gain object with a value of 1. Remember that for later. But like I said, we can chain these nodes together. If I take my oscillator node, I want my oscillator node to connect to my gain node, and then I want my gain node to connect to my speakers. So we can do that simply by calling connect and passing in my gain node. Now, the return of connect is the thing that we just connected to. So we can chain off of this another connect to connect our gain node to our speakers. So we press that. And then I'm going to start my oscillator node once more, and it's going to be an appropriate volume. And now, if I take my gain node and I go into that gain object, and I modify this value here, let's say from 1 to 0.2, still playing, but we've modified the output of oscillator node in our gain node and outputted that to our speakers. So things can get really complicated really quickly, I'll be honest with you. So we have a lot of different audio nodes that we can create straight out of the context, but what if we want to create our own node with custom processing? Well, we can do just that. We'll head on back into this presentation. So we can do that by extending an interface called audio worklet processor. When we extend this, we must implement a method called process. Process is where all of our fun stuff is going to happen. You'll see we take in 3 arguments: input channels, which is going to be what's passed into this node. Output channels is the thing that we're going to modify to send on to the next node. And then parameters, we're actually going to kind of ignore parameters for the purpose of this talk. Things get a little more complicated, and I don't have all the time for that. We don't return, you'll see from the process method, the output channels. We actually return a Boolean value. This Boolean value will tell the browser how to deal with this node. If we return false from process, it'll tell the browser, hey, if this node is not taking in data or creating data, you're allowed to terminate this node. If you return true, you're telling the browser, hey, you're not allowed to terminate this. We're going to handle this node on our own. And for all of the demos today, we're going to be returning true from this process method. Once we have defined our class and extended audio worklet processor, we can then register our processor by calling register processor. The first argument is going to be the name of the processor that we're going to be able to refer to later to create our node. And then we're passing in our class as the second argument. Now, notice one thing I'm specifically mentioning at the top, that this is in a different file from maybe our main.js or our script.js. This processor will, via the web worker API, run on a massive quotations separate thread. So that's going to help reduce visual jank or mucking up the DOM with trying to do this processing on the same thread as all that's happening. If you try and create this class and extend to this audio worklet processor on the main thread, it's actually going to throw you an error. So once we have created this processor, in our main.js, in our main thread, we can take our context and call add module and pass in the name of the file that we declared our module in. And then once that's done, we can create the node by calling new audio worklet node, pass in our context, and pass in the name that we registered our processor with. Then we have a custom audio node that can connect to other nodes, just like all the other nodes that we saw, but it has our own logic inside of it. Now that we've covered all that, we can now finally look at the start audio processing function. This is a very basic example, but the meat and potatoes is at the very bottom here. We're taking in the media stream from the microphone after we've gotten consent from get user media. We're adding the module. We're creating a new node, referencing our custom node. And then I'm creating one more node. Excuse me. Creating one more node. I'm calling it mic node, and I'm calling create media stream source and passing the stream we got from the microphone. This node is going to act as our input from the microphone. Then I want to pass what I get from the microphone to my custom processor, so I call mic node.connect to my custom processor. And then we're off to the races. Now we're sending data to this processor, which, like I said, is happening on a separate thread. Once we're done with that data, how do we get it back out to the main thread? Maybe we want to take that data and update the UI in some way. Well, by extending audio worklet processor, we have access to this parameter called port. With port, we can send messages out and declare how a thread should handle getting a message. So on our processor, very simple, we take the port and we call post message. Whatever we pass into post message will be sent out to be received by another thread. You can pass anything in here. I'm just passing, some very important data after doing a lot of important things. And then in our main.js, the way that we can take this data in is once we've created the processor node, we can access that port again and set on message to a custom function to deal with whatever we get from that node. So you see we're taking in this event, and I'm just logging out the data that we get. In this case, we should get that hello that I sent out from the custom processor. So now putting it all back together, first we must, to read real-time data, we must gain access to the user's microphone or their audio stream. We must register our custom processor for doing stuff with Essentia. All of our Essentia stuff is going to happen within that process function. We're going to add that processor to the audio context. We're going to create whatever nodes that we want, in our case, our microphone node and our custom processor node. And we're going to connect them together. And then we're going to feed that media stream into our chain of nodes there and start doing some fun things with Essentia. Once we're done with that, we can send the data back out to our main thread and do whatever we want with it. And then after that, register your LLC because, you're creating a crazy application here. So we're going to move on to our demos here. We're going to come back to this guy that we saw at the very beginning. So what you're seeing here, and I'm going to start this mic again. So it's actually not asking me for consent because I've been on this page before and already consented, but you'll see if I take this to, let's say, an incognito browser. I'm just kidding. Well, when you visit this page for the first time, you will be asked for your consent. If I start this, and again, just a little note about my setup here.
You're gonna have to turn up your speakers.
Okay. Hell yeah. No, thank you for looking out though. So just a little note about my setup here. I have my keyboard, which is connected via a USB cable. And when we call get user media, conveniently, my laptop doesn't have a microphone, so we're only getting my input from my keyboard.
Would that be the same as if you connected it with 3.5mm, like an audio cable?
Yes, yes, and also if you have, however
So you work on a non-MIDI content.
Correct. Yes, correct. So if I start this up again and I start playing, we're getting that media stream from my audio. And I have my custom processor with some Essentia algorithms to extract the data that we're writing to this graph here. It's just a canvas element that we're writing this data to. And we're passing that back out via the port. And I'm writing to the UI. So this is what's called a spectrogram, if you're not familiar. Spectrograms are used for visualizing a spectrum of frequencies, used in many different disciplines, including, of course, audio, music. Also things like seismology, visualizing the frequency of vibrations of our Earth's surface. So what we're seeing here on the left side, we have a sort of a measurement of frequency, and I'll get to that in a second. And then our x-axis is time. So this is actually a variant of a spectrogram called a MEL spectrogram. MEL is short for melody because someone was feeling very creative. Really, the reason that we have a mel spectrogram instead of just a raw spectrogram is it's a sort of way to normalize the data for a sort of perceived frequency. The weird thing about frequency is it increases faster than we typically perceive it, right? Like C and D at the very top, those sound the same distance away as C and D at the very bottom, but the difference between these two at the top versus these two at the bottom is much, much, much larger. To give you an idea, at the very bottom, this like mud tone is, I think it's around 24, 25 hertz. As we saw earlier, A in the middle of my piano is 440 hertz. So you would think the very top of my piano is 880 hertz. It's actually over 4,000 hertz. So the mel spectrogram normalizes the frequency data to be, to feel more normal for us when we're looking at it. Only really used for audio and music analysis. And then our second demo here, so that was a demo of getting our real-time data. Our second demo, sorry to blind you, is going to be an example of taking in an uploaded file. So I have a file upload here, and I'm going to pass in a song, and we'll give it a listen real quick. I think it's kind of fun. Okay, it's 10:30, ready to party. So kind of a fun, like upbeat, might I say, danceable song. And we're going to pass this file into our application, and it's going to use Essentia to interpret the mood of the song, and also give us our BPM and our key. So we'll upload this here, and that is actually. So you see on the side here, we have different ratings for the different moods of this song. Our tops are danceability and happy. I don't know about you, but I would kind of agree with that. Our BPM is 130. You can validate me on that later, but Staying Alive is around 100. I think that song is a little faster than that, so I believe 130. And our key is F. Let's kind of interrogate that a little bit. F minor. Yeah, kind of doing like a. Right, so it correctly found out what the key and the BPM of the song is, and assessed the mood of the song, all using Essentia. Again, we're taking in the file. We are, and again, this process is a lot simpler than the real time, but we're taking in the file, we're getting the byte array, and then we're passing it to Essentia to do some fun things. And then getting that data back out and writing to the UI. Yes.
How does Essentia decide happy and reliant?
So something I kind of missed a little earlier because I was like, what? Essentia also can interface with TensorFlow machine learning models, and also comes with a lot of pre-trained models as well. And we're actually using one model for each of these moods. There's a model for danceability, there's a model for happiness, model for relaxed and sad. So we're applying that machine learning model that Essentia just gives us out of the box to our input. So that's it for our demos, in case, unless anybody wants to send me a song for me to analyze here. But we're going to come back here. And we're going to open the floor up to any more Q&A. That's my talk, yes.
How do I obtain Essentia.js? The CDN is how I would download it. Do I have to pay for a license, an API key?
So if you want to use it in a professional sense, you will need to get a license for it. But just to mess around with it as a developer, you literally just install it.
I'm extremely interested, so I just wanted to make sure.
I'm happy to hear that. Any other questions? Yes.
Yeah, what's the code look like for the processes that you built for the craft?
All right. So I'm happy you asked. I'm happy and a little scared that you asked, to be honest.
He's really nice in code reviews.
So, so we come. Did you want to see a particular one, a particular demo? or-
Just the one that you were just showing, like the graph, the frequency graph. That's
The frequency graph.
With the Mel band?
Yeah.
Cool.
It's not my band.
So this is going to be. There's a lot here for drawing to the canvas, to be honest with you. But you'll see we are we are listening for the click of that button. Heard. Can you zoom in? Oh, you can. Well, hell yeah. So we have our on-click handler, and at the end of this, we're calling our start stream here, and then we're doing our check for if get user media is available to us. We're calling get user media. Again, we're passing true for audio, false for video, because we only want the audio stream. And then we are taking in our start audio processing function. So once we get in here, we're doing a bunch of extra stuff here. We're passing in our stream. We're checking if our stream is active, resuming our audio context if it has been suspended. We're creating our mic node. We're creating also a gain node here. It's kind of a quirk of the audio nodes. I was just kind of forget about the gain node for right now. And then we're loading kind of in a different way. We're loading our files, and we're also loading our custom processor here. And then we are adding that to our context and calling this function. And our processor. So you see, we have our processor here that is extending this the worklet processor that we saw earlier. We're doing a bunch of extra stuff. One thing to note here on the ports, we're defining on message. So the thread communication can go two ways. So we can actually pass data other than the stream to our processor. And then we have our process function. We're taking in our input and our output. And again, something to know about the process is we don't return our output array, we just modify it, and then it will automatically get passed on to the next node. And then in here, we're doing all our fun stuff. You'll see we're calling Mel Spectrum Extractor from Essentia. Extractor is just being set to our instance of Essentia. We're calling Mel Spectrum Extractor, and then we're taking that and we're doing some extra stuff. So we're using a ring buffer here. We're enqueuing the data that we get from this function to our ring buffer. Then we are outputting on the port to get back to the main thread. And then once we have it back in the main thread, we are doing stuff on the canvas to write the to the UI. So yeah, it gets a little complex, and you will have access to this code via this QR code here as well.
Which QR code?
Sorry.
Which QR code?
Oh, it would help if it was on screen, I think. Any other questions? Here, I'll make it even bigger for you. Yeah, this has, including code for the demos, it also has live demos that you can go to right now. The two that I showed are live. There's more demos to see. You'll see all the code. There's also documentation and articles on everything that we've talked about, including my contact information. And yeah, if you build anything with Essentia.js, email me. I'll be so happy to hear that.
You'll get an email.
Oh, thank you. Are there any other questions?
Having not worked with like media streams before in the browser, I'm wondering how crazy you can get with the sample rates inside of your processing.
I'm not too knowledgeable about sample rates, but you can. That's all going to happen via that parameters that we saw earlier in the processor, in the processor function. You can change sample rates and stuff like that. Aside from more complex use cases for that, I'm honestly not as familiar. So I apologize for that.
It also depends on your input mechanic.
Sure.
Because only USB can only carry CD level quality, and you have to use a fiber cable to get higher than that, or like your cable matters. You're always limited by the
Yeah.
lowest bit rate you can push through it.
Yeah, yeah,
Sorry, the
exactly.
highest bit rate you can push through it.
Yeah, certainly. So yeah, you can definitely mess with it. I'm just not as familiar with it. Any other questions? Yes.
So if you had like multiple, I don't want to say devices, let's say instruments. So you have a piano, an electric guitar, microphone, like a whole band basically, and you wanted to pipe it through this single application. Is there like a mixer you would have to feed it through and then it separates the streams for you so that you can then pinpoint those streams with like different audio worklets? Or how would that actually work processing wise? And do you see any lag
So
when it's processing the sine wave or whatever?
Sure. So there is a function on the navigator object in addition to get user media to give you a list of all of the media streams available to you. I do believe get user media will give you all of the media streams together. But I think you can also then tell it like which one you specifically want if you really wanted to. And then as for processing these different streams, there is the chain of nodes that you create, like your custom processor. It doesn't have to be a purely linear chain. There are nodes available to you for fanning in and out and creating more complex, processing chains. As for like lag and latency, in the Mel spectrogram example, we are using a ring buffer to, like, we're going to be losing some blocks of data if the ring buffer is completely full, but we're using that to kind of like throttle what's going back to the front end. We are doing a ton of processing, so if you have a crazy enough chain, I imagine it might have some hit to your performance. But I've not worked with like chains that crazy or taken in like two streams at once. But that's off the top of my head what I would imagine you would do.
What is your current sine wave in that example? What is it set at for processing? Is it like every second it's just sending a response back, or is it like as it receives a response, is it going as live as possible?
So yes. So what's going to happen is things are going to be added to the ring buffer, and then they're going to be sent back and processed. And once that's done, it's going to remove it. If the ring buffer is completely full, it can't add anything.
Okay.
So that's what I mean by like, if it's full and the processing is taking a sec, you might be losing some of that data with this implementation.
Do you set a memory allocation in the WebAssembly connection with like how much memory you're actually expecting to take up?
I'm not quite sure about that actually. Sure. Yeah. I'm not sure about that, unfortunately. Any other questions?
Yeah, is the import just a function of like the sample size and the sort of like the window, or like the sample rate in the window? Like just thinking about the input and the output of that processor, I assume that's like a, say, cut out a 1 second chunk, or I'm sure it's a lot smaller than that.
Yes. Yeah. So it's what you're getting an array buffer for a piece of time.
Which it defines up when you initialize the node, right?
I believe so. Yes. So yeah, you're getting the array buffer as a chunk, and I'm blanking on how much data you get per like run of process. But yeah, you're getting chunks of array buffers of the input.
Okay, that's what I was asking too. So I think you kind of answered that at the same time.
Gotcha.
Yeah.
Any other questions?
Sorry. How lightweight is Essentia.js on portability? If you were to produce the app, could someone with a Chromebook access the app and not have noticeable? Have you ever had an experience with different computers and the ways that they would interact with it?
Yeah, trying out the live demos on different devices, it seems to work pretty darn well.
When you're just stringing oscillator nodes, it doesn't work on phones.
Sure. But yeah, it seems to work for how much is happening behind the scenes. It seems to work really well. I think a lot of your like performance, I guess not really performance gain, but like I think a lot of your performance comes from that processing happening on that other thread with the web worker. So depending on how you handle that, I think, you can run this on.
But they'd be consumer, I assume the server, or whoever's serving the website would do as much of the processing as they could, so that
Sure.
makes sense.
Sure. Any other questions? We got some good questions.
Fleeting Note is available widely, by the way.
Well, there
You can use it on phones. It's available. Used it. I don't know if I would, but
Yeah, no, the context that I was just speaking from is when you're only using oscillators and you're only using them on the web page, so that their phone has to do both double duty.
yeah.
It after 10 notes, it starts to have like misalignment of time.
Got it. Okay.
It's weird.
Any other questions? Well, I'm going to call it there. Thank you to RBA.js, and thank you to all of you for humbling me and coming to my simple presentation. Like I said, this QR code, if you scan this, has my contact info, in addition to extra links that you might find helpful, and live demos and the code for those demos. So thank you so much, everybody, and you have a great rest of your day.